Hi everybody, let's go ahead and talk about the third characteristic of similar figures. This is day 3. Okay, so let's review a few things. Similar figures have the same shape, but not the same size. Similar figures have corresponding angles that are congruent. Okay, so those are our first two characteristics. So now we're going to take a look at their sides. Okay, so corresponding angles are congruent. So let's take a look at their corresponding sides. It says write the ratios of lengths of each side of triangle ABC to the length of the corresponding side of triangle LMN. What is true of these ratios? So take a look. AB corresponds to LM, that is in blue. AB is 7, LM is 21, and when we simplify that ratio, we get 1 to 3. Let's take a look at BC, which is in red, that's 5. And MN is the corresponding side, which is 15. If we simplify those ratios, we get 1 to 3 as well. So then we look at the last one, AC, which is in green, to LN, which is in green as well. And we get 8 to 24, which simplifies to 1/3, or 1 to 3. So when you look at them, all of these ratios are equivalent. So because all of the ratios are equivalent, or congruent, it is proportional. Okay? So the ratios of the lengths of corresponding sides of similar figures are congruent or proportional. All right, so with that said, we're going to go ahead and take a look at a few questions on our ImageMate to help us understand, or Elmo, to help us understand corresponding sides of similar figures are proportional. So the first thing that I'm going to do is I want you guys to take a look at number 1. And when we take a look at the corresponding sides, we want to go ahead and color code it a little bit to help us understand what it looks like. So put this one in blue. All right, so that side is blue, this side is blue. Okay, now notice how that ratio, if I go small to big, this is our small, this is our large, and set up those ratios. Ratio side is 18 to 24. Now if I simplify that ratio, simplify by, I see a common factor of 6, so we're going to divide by 6. And we get 3, and 24 divided by 6 is 4. So the ratio is 3 to 4. So if I continue with that same situation, now notice how the other side, because it is an isosceles triangle, is the same. So I'm not going to worry about that one, but I am going to worry about this one down here. So these two sides are corresponding. Small is 12, 16. And if I simplify that, they both have a common factor of 4. We get 3 to 4 as well. Okay, so because these are equivalent ratios, they're both 3 to 4, this situation is proportional. Okay, so it is proportional, and therefore it is similar. Okay, all right. So let's take a look at another example. Let's go ahead and take a look at question number 2. Question number 2, we have to look for our corresponding sides. Now, sometimes it's hard for us to figure out which ones are corresponding, especially when they're flipped like this and rotated. But I typically take the smallest side length. So since 9 is the smallest side length, we're going to correspond that with the smallest side length on the larger figure, which is 16. Okay, so let's make this small to large. Okay, small to large, right? And we're going to correspond 9 to 16. Now, when I look at those two, there's really nothing that I can simplify those by because there's no common factor. Because 9 is divisible by 3 and 16 is divisible by 4. If you think about them, those are they have perfect squares. The square root of 9 is 3, square root of 16 is 4. So let's go ahead and take a look at some other sides. So the next smallest side would be 12. Highlight that. And between these two, the next smallest side is 26. So we'll look at 12 to 26, that ratio. So remember, it is small to large. Now, one thing that you could do is come down here and write it. So 12 over 26. And I'm going to want to simplify that. So they're both even, so I'm going to divide by 2. And when I do that, I get 6 to 13. Okay, now notice how 9 to 16 is not equivalent to 6 to 13. Okay, so since the ratios are not equivalent, okay, so 9 over 16 is not equal to 6 over 13. I don't need to go any further, okay, and I'm going to say it is not proportional. And if it's not proportional, it is not similar. So as soon as you see a ratio that is not equivalent, you can go ahead and say that it is not proportional and it is not similar. So I do want to take a look really briefly at some decimal problems. So let's go ahead and take a look at question number 3 here. So number 3, we are given, computer is deciding to talk to me. Okay, so we're good now. Okay, so when we look at those ratios, you can see that we kind of have an isosceles triangle again. Let's take a look at the smallest side, it's 3, and do another corresponding side to that. We'll do 4 and 5/10. All right, so if we do small to large, write that ratio 3 to 4 and 5/10. It's not a whole number. It's okay, but it's not a whole number. So one way to get rid of that whole number and to make it look nice and neat is for us to, we can actually multiply it by 10. Okay, so when we do that, we get 30 over 45. From there, we want to simplify, and you know what, I'm going to go ahead and simplify by 15. We get 2, and 45 divided by 15 is 3. So our ratio is 2 to 3. So now let's take a look at the other sides. Now, I don't really care about the other 3 to 4.5 because those are going to give us the same result. But I do want to take a look at the 6 and compare that to the 9. Okay, so 6 over 9, small to large. Simplify that, we get 2 divided by 3 to 3. Okay, now look, 2/3 and 2/3. Okay, so those are equivalent ratios. So they are similar. Okay, proportional and similar. Nice, guys. All right, so I am going to skip number 4 just because, and I want to take a look at the fraction down here at number 5. So number 5, they're kind of embedded inside of each other, but that doesn't mean anything. We just need to make sure that we set up our ratios. So let's take a look at this side. Okay. All right, so those corresponding sides, if we were to do small to large, okay, small to large, and I write it, this side right here for the small triangle is a 3, to large is a 12. And when I simplify that, simplify by 3, I get 1 to 4. I wonder if it's going to give us a 1 to 4 ratio for the rest of them as well. So I'm going to go ahead and take a look. Let's do this side to this side right here. All right, so that ratio would be small, 2 and 1/4 to large, 9. Ooh, that's an interesting looking fraction within a fraction ratio. But we can go ahead and we can actually increase it in size. So you know how up here we increased and multiplied by 10? Well, down here what I want to do is I kind of want to multiply by 4 because 4/4 is equal to 1 whole, right? So watch what I do. I'm going to change this to an improper fraction first by doing the Texas 2-step. So 4 times 2 is 8, plus 1 is 9. 9/4 over 9. And then I'm going to multiply it by 4 to get rid of that denominator. Okay? Over 1 times 4. Okay. Now, these guys simplify each other out. 4 divided by 4 is 1, so I'm left with 9 over, and 9 times 4 is 36. Now, if I simplify that, notice that it's a common factor of 9. We get 1 to 4. Okay, so far so good. 1 to 4, 1 to 4. So let's take a look at the last one, which would be 3 3/4 to 15. Okay, so we're going to write small to large, 3 3/4 to 15. Okay, again, same thing. I want to multiply by 4 to make it nice and perfect for us. So I'm going to do my Texas two-step. 12, 13, 14, 15 over 4. Oh my goodness, I think it's going to work out. Okay, now I'm going to multiply by 4. Whatever I do at the top, I do at the bottom to make it an equivalent ratio. All right, and now I'm going to simplify that. And I get 15, and 15 times 4 is 60. Now I want to simplify by 15. But wait, didn't we just multiply by 15? Oh my goodness, craziness. Watch this. Okay, and 60 divided by 15 is 4. So now look, as you guys can see, I have equivalent ratios for all 3 sections. So equivalent ratios means it's proportional, and proportional means that it is similar. Okay, so I'm going to write proportional and similar. Now, I know I didn't do all the problems on the paper, but I think you guys have a good idea of what I'm expecting you to be able to do. All right? Okay, I'll talk to you later. Bye, guys.